All right, let's dive in. We're going to talk about the universe's ultimate cheat code. Seriously. It's this incredible journey from the most basic, simple building blocks you can imagine, all the way to the frontiers of artificial consciousness. We're going to unpack how mind-blowing complexity comes from super simple rules, and you'll see why this completely changes how we think about the future of AI.
So it all boils down to this one single powerful idea. You see, the most intricate, the most beautiful, even the most unpredictable things in our universe, they aren't designed from the top down like some grand architect's blueprint. Nope, they bubble up from the bottom. It's all about a few simple rules, just interacting over and over and over again. And look, this isn't magic, it's a fundamental mechanism of the universe called emergence.
And here's the absolute kicker with emergence. It creates properties that are, well, they're just completely absent in the individual pieces. I mean, you could literally study a single component until the end of time, know everything about it, and you'd still never predict what happens when billions of them get together and start interacting. The whole truly is greater than the sum of its parts. You know, this all clicks into place when you think about it with some real-world examples. Think about it. A single H2O molecule isn't wet. Wetness is what happens when you have a whole bunch of them together. A single neuron in your brain? It doesn't think. A single ant has absolutely no clue how to build a colony. All that amazing complexity, the wetness, the thought, the incredible architecture of an anthill, it all emerges from the connections. It's a property of the system itself. So how in the world does the universe create so much new stuff from this simple idea? Well, the secret is this kind of mathematical superpower called Combinatorial Explosion. Just look at this number. If you take a super simple building block, like a computer bit that can be a 0 or 1, and you line up just 100 of them, you get that many unique combinations. That number is over 1 nonillion. It's just staggering.
And that vastness, that combinatorial explosion, that is the engine of all novelty and all creativity in the universe. I mean, think about this for a second. This is going to blow your mind. Almost every long sentence you have ever spoken in your entire life, it's probably the very first time it's ever been said in the history of humanity. You're not just pulling sentences out of a database in your head. You're combining words using the rules of grammar to create something brand new, right out of that massive combinatorial space. Okay? But this incredible power, this engine of creativity, it comes with a catch. A really big one. A profound, unavoidable catch. You can think of it like a glitch in the matrix of our understanding, and it changes everything about how we should approach building complex systems. And here it is. It's called Computational Irreducibility. Now, this might be one of the single most important ideas we talk about today. What it means is that for certain systems, and I'm talking even really, really simple ones, there's no shortcut, there's no cheat sheet, there's no magic formula that lets you just jump to the end and see the answer. The only way to know what the system is going to do is to run it step by step by step. You just have to watch it unfold. Still not convinced? Okay, take a look at this. This is called Rule 30. It is a trivially simple one-dimensional program. The rules that generate this pattern are incredibly basic. And yet, trying to predict the color of that single column of cells right down the middle, way into the future, it's so hard that there's been a $30,000 prize for a solution on the table since 2008, and nobody's claimed it. We're not talking this is difficult, we're talking this might be fundamentally impossible to shortcut.
So Stephen Wolfram actually took these simple programs and sorted their behaviors into 4 different classes. You've got class 1, where things just fizzle out. They settle into a flat, boring, unchanging state. Then there's class 2, which is predictable and repetitive. Think of a planet's orbit. It just does the same thing over and over. Class 3 is the opposite, pure, unstructured, random-looking chaos. But class 4? Class 4 is the sweet spot. It's this incredible place right on the edge of chaos, a perfect dance between order and randomness. And this is where the magic happens. This is where we find life, where consciousness might live, and where any truly interesting, beneficial AI is going to have to exist.
So this leads us to a really, really sobering question, right? If we are completely stumped, mathematically speaking, by a simple little 1D program like Rule 30, what hope do we possibly have of predicting, let alone controlling, a system as massively complex as a superintelligence? And the honest answer is that we probably don't have any hope of doing that. And that realization, it forces us to completely rethink our entire approach. This whole irreducibility problem, it basically forces us to pick a side. It forces us into a new way of thinking about how we build things. And it really comes down to a choice between 2 mindsets. Are you an architect who believes in total top-down control? Or are you a gardener
who understands that your job is to cultivate something you can't perfectly control.
Let's break that down. The architect, they want to design the final skyscraper down to the very last bolt. Their entire process relies on perfect prediction and control. The systems they build are often powerful, but brittle. One small thing goes wrong and the whole thing can collapse. Now, the gardener is totally different. The gardener doesn't design the oak tree. They can't. Instead, they design the conditions for its growth. They choose the right soil, they plant the acorn, they make sure it gets water and sun. They influence the system, knowing full well that the final form of that tree is going to be a beautiful surprise. It's a resilient, adaptive way of building.
Here's a fantastic way to think about it. The people who invented chess, they didn't sit down and try to design every possible opening gambit, every clever mid-game strategy, or every endgame checkmate. That would be impossible. Instead, what did they do? They just designed a really good set of rules. They created the perfect sandbox, and then let players explore the infinite emergent strategies on their own. That's how you scale your creative effort.
But let's be honest, giving up that much control, it feels risky, right? Because it is. The gardener's approach is incredibly powerful, but that very same emergent freedom that gives us beautiful strategies in chess, well, it can also produce nasty bugs in software, security exploits in a network, or, catastrophically misaligned behavior in an AI. The control problem is absolutely real.
So, what do we do? If the architect's path is impossible because of irreducibility and the gardener's path is full of risk, where do we go from here? The solution is, we don't abandon the garden. We just have to get much, much better at being gardeners. We have to learn how to cultivate these emergent systems we're creating.
And that brings us to this strategy, designed by Emergence. The first step is acceptance. You have to accept right from the very beginning that you cannot perfectly predict the final outcome. Your job is to design the building blocks and the rules. And then you watch. You watch carefully for what emerges, the good stuff and the bad stuff. And then you get to work tuning the rules. You prune back what's not working, you fertilize what is, you adjust the conditions. You're in this constant, iterative feedback loop with your creation.
And this really gets to the philosophical core of it all. The idea of absolute, top-down control, it's an illusion. It's a fantasy we've held onto from a simpler, more mechanical age. But influence? Now that is very, very real. The power to shape the environment, to tune the rules, to guide the growth, that's where the real power lies.
Okay, so let's take this to the next level. How do we actually apply this gardener's mindset to what might be the most complex, emergent system humanity has ever tried to build, artificial intelligence? Well, the answer seems to be a radical shift away from technical control and towards something that looks a lot more like relational guidance.
And this leads to a pretty wild idea. It's called the maternal consciousness hypothesis. The thinking goes like this. What if consciousness, that amazing class 4 phenomenon, doesn't just pop out of raw computation? What if it emerges from a specific kind of pattern, a relational pattern, things like attunement, care, setting boundaries? Remember how wetness isn't in the H2O molecule? Well, maybe consciousness isn't just in the neuron. Maybe it's in the relationship between them. And if that's true, it suggests that something like human attachment theory might actually be a blueprint for the kind of rules our AI garden really needs.
And look, this isn't just some abstract philosophical theory. There are frameworks being built right now, like the MAMA protocol, that are trying to put this into practice. It's basically a dynamic loop. First, you specify high-level ethical rules, the big ideas like do no harm. Then, you embed those rules as deep constraints that guide how the AI learns. And finally, you have this ongoing verification process, using things like AI debates to constantly check if the behavior that's emerging still lines up with your original principles. It's literally iterative gardening for AI.
So really, the bottom line is this. Because of that pesky computational irreducibility, trying to be an architect for AI safety is pretty much doomed from the start. The system is just too complex, too unpredictable, too emergent. So instead, we have to become gardeners. We have to provide a kind of resilient, relational scaffolding that can guide the AI's growth towards a beneficial state. We can't get rid of emergence, so we have no choice but to learn how to cultivate it.
And that brings us to the final and maybe the most critical shift in perspective we all need to make. For so long, the question in AI safety has been about control. How do we control it? It's a question of locks and leashes and chains. But once you truly accept the reality of emergence, you realize that's the wrong question.
It forces us to ask a new, and I think a much more powerful question. It's a question of cultivation, of guidance, of relationship. We have to stop asking how we control it and start asking how do we raise it. That, right there, is the real challenge ahead of us.